Can you hear me now? You know, the music probably sounds better anyways. Sweet. So, I had this cool explanation and everything, but let me go over it again. This is the third stream for me, which is great. Still working out some kinks. This is the third streaming software I've tried. Hopefully, we are we nailed it this time. Like, you can see my screen, everything's normal colors. I even took some time to make a cool background, put in some information about what we're working on today. And got some royalty-free music to play. So, raising the quality just for y'all. Um, yep, just straight OBS. Uh, so today we are going to be working on a new analyzer. I did a Twitter poll, so if you're interested in influencing kind of what streams happen in the future, follow me on Twitter. That's where I usually post about what's going to happen on streams. But today, y'all wanted to see a new analyzer, so we will jump right into it. We're going to be working out of the .NET Roslyn Analyzers repo. And so I went through, just looked for an issue. The Roslyn Analyzer repo also has a help wanted tag if you're ever interested in finding just random issues that you can pick up in there. And feature requests. So feature requests will be new analyzers or extending analyzers to be, covering new scenarios. So I'm going to be looking at one that I think is pretty good for an introduction into analyzers and kind of a general idea of how to write one. So Yusuf filed the bug on this one, and I think it's a great one we need anyways. So this is to add a generator attribute to source generators. So the easiest way to explain this, I think this link opens in this here. So this attribute is required for all source generators when they get exported, so that way they're used correctly. And if you're missing this, if you're missing this attribute, source generator is not going to work at all. So pretty important. We have a generator or a thing that's similar to this, where we do missing diagnostic analyzers. So you can see if you ever write a diagnostic analyzer, here's some example code. We make sure that we include the diagnostic analyzer attribute. So we want a very similar thing, but for source generators, right? So hopefully pretty straightforward. We're going to start the same way we usually do. We're going to write a few tests, and we're going to explain source generators a little bit, because I think this is a good segue into explaining how source generators work and kind of just how to write a base one. So we do have, I didn't actually have this pulled up, but we do have a source generators cookbook that you can look at. And I'm actually going to use the cookbook here for some examples on how I'm going to write my tests. So you can see the generator here implements iSource generator, and we need this generator attribute. So basically, I'm going to copy this into a test and remove this generator attribute, and then we want our test to add this generator attribute. So let's get started. Oh man, I kicked off this build right before stream started, and it worked, and I'm pretty excited. It's the small things. So yeah, let's go ahead and get this started. So if we go back to this and we look at where the missing diagnostic attribute is, we kind of want to put this in the same thing, because it's basically the same idea. Like, both of these are Roslyn APIs that you would be implementing. So we're going to put this in the meta analyzers. Generally, bugs and stuff, if you have a question about where an analyzer should go, this is a good place to ask. But this, since it's pretty straightforward, we're going to put it basically in the same spot. So we're going to put it in meta analyzers right next to the missing diagnostic analyzers. So we're going to put our test there, and we're basically just going to follow what missing diagnostic analyzer does. So if we search for missing diagnostic analyzer tests, hopefully pull this up. We'll just find this over here, and we will just add a new class. Oh yeah, first time loading templates, always fun. All right, so we are going to be adding this. Let's just call it missing generator attribute test. Rule test. Apparently is the general way we do this. Okay. If we go back here, so there's a few things to note about the Roslyn analyzer repo, and we do have this in the Roslyn repo as well, but we have this tools like test utilities that we use that do make things a lot easier. So you'll see this kind of used across the board, and what we do is we usually use the using statement, split this up between verify CS and verify VB. In this case, I believe we're going to want to do both, but we're going to start with CS first. So let's just copy this, and you can see that this will have the analyzer and code fix. If there is a code fix, we are hopefully gonna write both today. So we will have to rename this, but it should go in the same spot. And then make sure the namespace is correct, and we should be good. And then let's make this public. And for now, let's just call this test 1. We will come back and call this a better name soon. But we are going to copy this code. Remove the generator tag here. Escape these. Oh. Escape them the correct way. And life should be good. Okay. So this is going to be our original code. And then we want the same thing. We're going to call it fix code. And we want this to have a generator. So there's a few things. Oh, yeah, I can totally zoom in. I totally forgot to do that. Let's do that. And let's hide this. It'd be a little easier to see. Quick question. What version of .NET am I on? That is a good question. Let's check. I'm on 6.0.1 preview 5. It is hard to keep track of the previews. In general, if you're working out of Roslyn, we do have or any .NET repos, we do have the .restore. Oh, my console did not like being resized, but we do have the restore command, and if you run that, it will download what it'll do is it'll restore projects, and you can see it'll check what .NET version needs to be downloaded, and make sure you have those available so you can build. That's really the easiest way. You might still have to install .NET SDK on your machine separately, but this will at least give you a good indication of what the requirements are. Since I've already run this, this won't output as much as it normally does. Okay, so the other thing to note about this generator tag is we need to make sure it exists. I'm going to check real quick how this gets included here. I believe fix code with C# attribute, source. Okay, cool. So it looks like As long as we include the correct namespace, um, we should be fine here. I don't actually know what the correct namespace is though, so let's see if we can leverage the idea a little bit on this. Um, Imagine it should be Microsoft Code Analysis Diagnostics. Okay, so it's the same as the Analyzer one, which is great. So we'll make sure this gets added here. And then this should be a task, because this is going to be asynchronous. And then all you have to do is verify CS. Verify we were going to run code fix async, and we're going to call this on the original code and the fix code. So this will do a few things. One, we don't expect this to pass now, but these verifiers do check for diagnostics. So a good indicator of like making sure we wrote our code correctly, and that this would actually compile. So like if we're missing things like iSource generator here, we would need to know that. We probably are missing a few namespaces, to be completely honest. So I'm going to shortcut that a little bit and just copy and paste this code into the editor and have it figure out what namespaces we're missing. Because I think iSource generator is not, it might be in the same namespace, but I'm not 100% sure. iSource generator could not be found. What namespace is that in? Come on, IDE. You can do this. Fine. Let's go look at the documentation. Just Microsoft Code Analysis. Okay. That's what I needed to know. Great. Basically, we want to make code that does compile. And then if we look at the generation context type, make sure that's also in Microsoft Code Analysis, then we should be good. Yep. Yeah, Nick's got it. All right. And then we just need to add a fact here. And let's run this. Oh man, wait. Nick Craver's watching me. I'm like, I feel like you probably actually know more about Roslyn and .NET than I do. We'll see. I feel like I need a game show for when I'm on loading screens. Yeah, I don't remember namespaces. Yeah, no, Roslyn is. So while we're waiting, I've only been on the Roslyn team for 2 years, a little over 2 years now. And I didn't really know much about .NET before that. So I'm still learning quite a lot. Okay. iSource Trainer could not be found, so we might be missing a reference there. Uh, did we change? Yeah, no pressure. Oh, jeez. No, a lot of smart people are watching me. No pressure. Let me get this all wrong. Uh, I also haven't written the source generator since like when it was in preview. So iSource generator ships in Roslyn 3.9. What version are we using to compile? I have no idea. Test state sources, expected diagnostics. So this actually isn't changing any of the requirements. This is just setting. I suspect tests don't reference Roslyn DLLs by default. Well, so the interesting thing here is that Microsoft Code Analysis Diagnostics, as like these namespaces, I don't know if they do. I thought they did. Especially because the attribute tests just include them, and I don't see anything separate about the test sources here. So the source is just this. There's no special logic for adding any additional things. I mean, to be fair, yeah, this is in Roslyn analyzers, not Roslyn's. Uh, yeah, I'm happy to have people who are not smart here as well to back me up. Yeah, so Roslyn Analyzers, I believe, uses the latest by default. So iSource Generator doesn't exist. All right. Let's do this. We have a few options here, and I'm going to do the first one that comes to mind, which is we're going to find all references on verify code fix because there's going to be places where somebody is referencing different libraries. And I know there's a way to do that, and I just don't remember. Oh, but this is going to be with, we don't want to find reference on that one because we're using just the strings. Actually, we want to find references on this where we're creating a new test. And, oh, actually, can we find references on test state? That might be the better way to do it. Sources, expected diagnostics. Yeah, I'm gonna go through these real quick because I've even done this before, and I can never remember the correct way. Minimal symbol implementation. I mean, at worst case, we can just write code that all of our tests use. Test A, additional references. Here we go. This is what I was looking for. So here's the default references, which should include the Roslyn assemblies, right? So if we look at the references we're adding here, is this specifically for VB? How do namespaces even work? There we go. Net core app 3.1. So those are the default ones. Default doesn't include Roslyn. The VB references for things like Seaster. Okay. Do you know, off the top of your head, how to include the Roslyn packages for these tests? Just add CS8032 as an expected error. Yeah. No, I could. Right. Is the code analysis one in the analyzer testing? Oh, thank you, Fred. Add metadata reference. There we go. Just what I needed. Test state. Does this have references on the... Here we go. Additional references. Hopefully this works. Okay. And then dot verify code. What? That's the way to write it, isn't it? Oh, run async. Always got to name it something different. And then we want our fixed code to be the fixed code here. Perfect. Yeah, it is great to have people on hand who know this kind of stuff. Because this is stuff that I just cannot retain. I use it once every few weeks and still forget it. Oh, but the secret line was literally code equals code. Yep. From public API proposals. Yeah. Do you like the discussions we've had so far on our public API proposals? And directly impacts a lot of this stuff, because Roslyn Analyzers only uses public APIs as far as I know. You're procrastinating from writing tests. What are you writing tests for? I'm not going to write them on stream for you, but I can help motivate you to watch me instead of write tests. Which is, by definition, still getting something done. This is cool. I've never seen this bug before. The test date didn't update even though they finished running. Here we go. Did that still not? I'm gonna run it again. I'm not sure. I don't believe it. Like it said at the bottom that it rebuilt and the tests ran and it still failed. But it's not really this is preview software. You know? The view code command for Razor files. Oh, yeah. Yeah, that'll be fun. Yeah, the UI enhancement here is actually, so when my boss asks why I'm not getting anything done, I say, oh, I was writing tests and I was waiting for them to run. We actually put that in as a feature because things are getting faster, so I have to find other ways to computationally procrastinate at my job. This still says missing an assembly reference for iSource generator. Sure. Only if it's searchable though. So really not, it might not actually be in there. If it requires a restart, I'm not doing it. Enable updated project properties UI, yeah. Use updated, it does require a restart. You'll have to wait till next stream. But it's added for later. Okay. This is still causing problems. Other than my spacing in code. Code analysis reference. What is this reference? So it's gonna be yeah, this should be correct. It's compilation. Yeah. Am I not writing my test correctly? All right, let's go back to the one. We'll do it. Create project. Like I would expect this to work. Metadata reference collection. Do we have to do it as reference assemblies or metadata reference? It has to be a... Oh wait, no. No. This is a metadata reference. Why is this not working? I would still expect this to work. So the one I used as a reference is working. Which is interesting because this also doesn't include the metadata references. So why do I have to if this doesn't? Yeah, the only complex thing this test is doing is generating the diagnostic results here. And that's because I think it uses specific diagnostics. So it generates the expected diagnostics first, and then has the fixed state. The other thing, just to take this out of the equation, let's take out the fixed code for a second. Because we didn't add that as an additional reference in our fixed code. Okay. Didn't think it was that, but you know, because it runs the expected diagnostics on the before and after, so I was wondering if it was actually reporting diagnostics on the fixed code because we didn't do reference assemblies there. Yeah, all of these are just array imports, system collections immutable. Is there? Yeah, this is all iSource generator. Are we using a version that doesn't have iSource generator in it? Wait a second. What version are we using here? 3.3. What version has iSource generator in it? That's why. Not new. We're not using a new enough library. Okay. Yeah. Yeah, 3.3 is pretty old at this point. Why are we referencing... These additional metadata references come from... Do we have a code analysis that's a higher version? It's 3.0. This is F3, right? Yeah. All right. Cool. In that case, since we're not using a new enough version, we're going to cheat a little bit for now. We're just going to go to Roslyn and find the definition for iSource generator. Yeah, it happens. As far as I know, it literally happens everywhere. Oh, I forgot. GitHub search is so terrible, but do we have these indexed? No. There we go. All right. If you can't succeed at first, fake it. We don't even care about all these remarks. Because we don't comment our test code. That would be lame. Then... I wonder if we're going to need the generator attribute as well. Probably will. But for now... probably gonna need this to be defined too. So let's just go ahead and pull this in. We just copy code. It's the real winning way. Who decided we can't auto escape things on paste? Namespace. Yeah, it will need a namespace. I'm just getting all of the code in here. Okay. All of this is public. We don't need internal definitions probably, but we'll leave them. Okay, so we need the execution context as well. All right. It's probably a better way to copy these, but this is what we're doing. The real way to do this correctly might actually be to see if we can update our reference, but I'm not willing to commit to doing that on stream, so. Perfect. Okay. And then these are all in Microsoft.code analysis. Go. There we go. Make our code look at least a little prettier so it's easier to read and see what's going on. Okay. Get rid of this extra line because I inevitably leave those in every time. Okay. So if you don't have a real reference, you can just make one up. As a fun fact. We are still missing the generator attribute, but I'll worry about that in a second. You remembered seeing this Roslyn issue. Escape characters on paste. Oh yeah. Yeah, I think we keep bugging the editor team thinking it should be a platform feature for all languages. But who knows? Maybe we should just do it. Okay. Hey, more diagnostics. The name source text does not exist in... Oh. It would help if my code that I pasted also compiled. I assume source text is Microsoft Code Analysis. There's also going to be... Let's get rid of the internal here because that references something. Action is... What namespace is action? Anybody know off the top of their head? It's just system, right? Yep. Oh, yeah. It's a good idea, actually. Just go to Sharp Lab and... Oh yeah, we're gonna have to do for cancellation token as well. We don't need this. We don't actually need to do any work here. We just need the things to exist. We can remove that. Generate class here. Compilation. I don't have to generate compilation, right? It's just going to be in code analysis. Parse options should be in code analysis. Immutable array. We want the using system collections immutable. Yeah, actually, anything internal or private we don't even need here. We don't need... Actually, that's a good question. What does the test call? That would be the best thing to do. Just minimize our test surface. Because we technically don't even need to do this. This is all we need. We just need these types to exist. In which case, they don't need to have anything in the middle. And that reduces a lot of this headache. Document highlights went away. Am I gonna... Seems like it's back now. Cool. So now, last bit we want to do is we want to match where it puts the diagnostic. And I imagine it puts the diagnostic on the class here. So let's see. That's all fixed code. Oh yeah, they do the create diagnostic 7 with location. This is gonna be line and column. Okay. Okay, so it's gonna put the diagnostic here. So let's just say we want a diagnostic here. But I think there's actually a different annotation for diagnostics. This is cursor position. I can never remember the annotation for diagnostics. But you know the easy way to find out? Go steal code from someone else who does know. Nope. We gotta find an easy one. Oh yeah, here we go. So that's if you need a specific diagnostic. We want the easy one. Man, none of these are... Why are all of our things require so much complicated things? I know there's an easy way to do a diagnostic. Oh yeah, it's this right here. That's what we need. Okay, that's what I was looking for. Sweet. Okay, so now if we run the test, it should fail because we're expecting a diagnostic here and we won't be getting one. Test-driven development. Sweet. All right, so let's change this to meta-analyzer. We want to do this as analyzer, diagnostic analyzer. Oh, it's probably a source generator analyzer. Attribute. Naming conventions are hard. Diagnostic analyzer, attribute analyzer. So source generator, no analyzer, attribute analyzer. And fix. Sweet. So we'll go generate these real quick. Could be test-driven depravity. Could be. Just notice the Windows 11 preview. Oh yeah, no. Rockin' Windows 11. Really enjoying it so far. My biggest complaint is that you can't hide the start menu right now, although maybe they fixed that. I just got an update this morning and I haven't tried. Yeah. Okay, so we want to create a new analyzer from scratch. Now here's where the magic happens. Dog. How's it going? What do we call this thing? It took so long to come up with this name, and I don't even remember what I called it. Okay. So there's a few pieces that are kind of important for an analyzer. You need to, this actually tests to make sure this exists, but you need to export it as a diagnostic analyzer. So you need this attribute, the languages it runs on. This is inheriting from a diagnostic correctness analyzer, which then inherits from diagnostic analyzer. So this just provides a base class for some simple things along the way. But we are just going to inherit directly from diagnostic analyzer. And we're only going to start with C#. So go back to this, copy and paste everything. And we're only going to use language name C# for now. And then I believe this needs to be public sealed, yeah. Cool. So as implementing a diagnostic analyzer, biggest complaint is that 11 is 3 whole syllables and it is exhausting. It really is. I was hoping we would at least do like Final Fantasy style if we're gonna make it long and do like 10-2 or something like that, but we just went straight to 11. Windows or Windows or maybe could call it Windows or. I wonder if that will catch on. I don't know if I completely agree that it will, but you know, you can just keep calling it that. Windows Spinal Tap, yeah. I think there was a Spinal Tap reference in the release video too. Okay, so we need descriptors for our diagnostic. This is going to be what is shown to the user. So there's a few things we have to set up. Setup is the hardest part for writing new tests and a new analyzer. So we're gonna copy and paste because these are basically gonna do the same thing. Missing attribute, we need a title, a message, and a description. But in this case, we want missing diagnostic source generator, message, missing source generator attribute message, and missing source generator attribute description. So these are going to be in the resources file, which is right here, the resx file. So all we need to do here is go to the bottom and we're going to add these three things. We're going to add our missing generator attribute there. Oh, I just copied the same one again. Close that. Wait, did they just copy title for the message? They did. I don't know if we'll need a different message, but let's make one for now. What? I literally just copied this. And then we need a description. Go add it. Ooh. Sweet. So when we save this, hopefully that generates these, and we're good to go. So all that's going to do is, if you've never used resx before, this generates localized data nonsense. But the idea, at the end of the day, is we have a source generator that makes these. And if you actually go to definition on these, you can see it generates all of this. It's pretty cool. And then it calls get resource key or get resource string. And these are the keys for the resource strings, which will then be localized. So that's how we kind of do our localization if you've never done resx stuff before. So all of these strings will get localized. So the next step is we need to make sure we're using them. We have supported diagnostics that we need to add, and we need to initialize. So let's do constructor first. I think. Is the constructor for diagnostic analyzer? Do you actually need to call that? I don't think so. Yeah, you just need to override. There we go. So we need to add the supported diagnostics. This tells what diagnostic we're actually going to be implementing here. In this case, so this calls it with, really? Interesting. Okay. Forget how to do these. So we're gonna go. I haven't actually written an analyzer in a bit. we can always copy some well-known examples. So we need to go to add a diagnostic ID. In this case, let's see, what is the... So these are RS because they're metadata things, so do we leave space in RS? Doesn't look like it, we just keep adding on. So let's just add a new one. Five. Oh, Zach's already heading out. It's good to have you here for a little bit, Zach. Hopefully, the streams are going to be uploaded this time. So they should be on Twitch for about 14 days or so. For those of you who can't catch this live. Okay, so we want to update our diagnostic ID. We have our title. I like calling these just localizable title message because these are private. Code analysis correctness. Warning is enabled by default as true. That's good. And custom tags. Okay. And then we just need to make this an immutable array. I wonder if target type new, does that actually work in? I think it does. We're just gonna create this diagnostic here. Because we only have one rule that we're really worried about for now. Yeah, and just immutable array create. But hang on. Let's see if I can get it right this time. Thought if you type create, it would catch it. But I guess empty does. Empty does for immutable arrays. Create may not. Oh, hey. I could become famous. Did you see that? Really should learn how to like mute and block people, huh? Yeah, I'm pulling in some big numbers. I mean, I actually have to learn how to manage my own Twitch stream soon. Okay. And then the last bit that we need to do is we need to register for when we're going to initialize. Should be able to turn on mod controls in my chat. Oh yeah, there it is, mod icons. Bam. Except my chat just went away, hang on. Streaming difficulties. Okay. Should have mod controls, but I had to like reload the chat. So the whole chat's gone now. How do you actually see the yeah, emote only chat, follower only chat, chat appearances, deleted, messages, pause chat, pop out chat. I don't know. I have the mod controls now, but I don't have that message in my chat to go back and delete it. So don't click that link. Or if you do, let me know how it goes, but don't do it. Okay, so we need to decide on a context that we're going to register for. So when you're doing an analyzer, there's kind of a few parts to this. So you need to identify what context, like when you want your analyzer to run. So the like syntax node action for when we're just parsing the syntax tree, the compilation start action for when we actually start a compilation. I don't actually know what syntax tree is. I've never used that one. It's completing a parsing of code document. Oh, okay. So it's when a whole syntax tree is done being parsed. And then there's different other ones as well, like code block action, operation actions I've used a few times. They're really good for the operation stuff. I'm not actually sure. Here's where the kicker is. So when you're compiling things, can you see it if we reply to it? I can see that you replied to it. And I see like a quote of it, but I don't actually know. You're so tempted to go to big follows. You know, I'm not the boss of you. Okay, David, I promise I will go at the snail's pace I've been going today. I don't know what it is today. I cannot like get anything to work for me in my brain. But hopefully this is at least entertaining to know that I'm a professional and this is kind of the rate I work sometimes. It's not optimal, but it's working. We want to look at the diagnostic analyzer attribute. And the reason being is attributes are kind of weird in Roslyn. And I never for the life of me understand where attributes are actually. And we've had discussions about this even recently, and it just blows my mind that it doesn't work the way I think it does. So this does base initialize. Hi, dog. Are you saying hi to the stream? So this does configure generated code analysis because it's analyzing. I don't think we want to analyze generated code, but maybe. I think I'm working on it entirely to watch your slow work. You know, I appreciate that. Okay, so this does a compilation start, which I think is kind of what I was guessing, because we don't really have a good way to do like an I operation or anything for this. And then it registers for symbol actions. And then it's going to analyze symbols, and it's going to be on name types, because that's where this goes. So more or less, this is what we need. And hopefully I can explain this for you. So when we're starting compilation, we get this context back where we're checking to see if the diagnostic analyzer, but we're going to change this to source generator, and the diagnostic analyzer attribute are present. And if they're not present in the compilation, we don't need to do anything. So that's kind of like the first step. And the way we usually do this is we have this well-known list of strings here. So you can see this is Microsoft Code Analysis, Diagnostic Analyzer. We're just going to add source generator to this. And all this is going to check to see is if that type exists. So diagnostic analyzer attribute and analyzer, we'll just put it right after this. Code analysis. I don't really want a tab to accept that. Diagnostics. The source generator is in the diagnostics. This is where I can use my test. Yeah, it was diagnostics. Although code analysis was the diagnostic analyzer, so we're just going to do code analysis. And then we're looking for iSource generator. Yeah. Double checking my names because, you know, we're typing these out. And I make a lot of mistakes. Like co-analysis. So we want to check to make sure iSource generator exists, and we want to make sure the attribute exists. I think the attribute is in the same namespace too. Microsoft Code Analysis Generator attribute. Yep. And we're going to actually add this to our test now before I forget. And then we just need this to be, I don't know if it's generator or generator attribute. I think it's generator attribute because that's the actual type name. Yeah, that's what analyzer does. Cool. So now we can check to see if iSource generator and the generator attribute, which I should have. There we go. And this is going to be so that's the first step. And we're going to actually write a test for this real quick. And make sure this hits. But basically, if these types are not present, we don't want to do anything. And then the second step is get diagnostics, simple compilation context. So this goes through and gets the correct analyzer for this, but we don't really need to do that because we're only doing it for our one specific case. So we just gonna register and we're going to analyze symbol. And we only want to work on name types because those are the only things that can be generators. We're going to generate this method. So the registration, pretty straightforward. Configure generated code analysis and enable concurrent. Does this actually fix this? I also changed these to var, which is kind of interesting. um, we do not want to analyze generated code. I do prefer var though. That's all I'm gonna say about that. Okay, so we can find the symbol that we're analyzing here. So we just want to do var symbol, simplicity's sake, and then what we need to do is check to see if we need to pass. I'm going to pass these types then too, because we need to know if this type implements this interface and if it has this attribute. So this should be an inamed type symbol, first of all. var. So we're going to do all interfaces here because we want to include base type interfaces as well. And then we want to check to see if any of these are our symbol. So these are going to be the iname type symbols that are the interfaces. So what we're going to do is compare this to the source generator here. So symbol equality compare. And if this happens, actually, we're just going to save this for now. So I guess the main thing is if this is not true, we can exit early. Then the next step is we need to get the attributes. So do we call get attributes or get applicable attributes? I think get attributes is only for this type, and get applicable attributes includes the base type. Gets all attributes directly applied to the type or inherited from base type. This is actually an overload. Okay. Let's just get attributes for now. And then we need to check to see if any of this attribute is equal to the source generator attribute. And then we want to use our symbol equality compare. I'm actually going to change this. Kind of prefer this style a little bit more. So in this case, all we're going to do is check to see if it already has the attribute. And if it does, then we can return. Otherwise, we need to report a diagnostic. So we're going to report a diagnostic. And the diagnostic we're reporting is from our diagnostic. I think this has a... Just trying to get this to complete for me. There we go. Diagnostic descriptor. So we want this to be our diagnostic rule dot description. Oh. Diagnostic rule, this is going to be the symbol location. Actually, does this have a location that it's actually doing? It doesn't. Okay. So we're just going to do symbol dot locations. We'll just take the first location for now. And we don't have any message arguments. Cool. Then just not access, we can make this static. So the idea here is pretty straightforward. Every time we have a symbol, we're going to take that symbol, which is by definition of our restriction of symbol kind name type. We know that it's an iname type symbol. We're going to check that symbol to see if it implements the source generator interface. If it doesn't, we're going to return because we don't need to analyze this anytime further. If it does, we want to check to see if that symbol has the attribute that is required. And if it does, we can return. And if it doesn't, we're just going to report a diagnostic on that symbol. Some tricks that might look a little weird here is like the symbol.location set first. I'm a little worried this is wrong because for partial classes and stuff, I don't think this is ordered in a specific way. I'm not 100% sure on that one. So we might want to look and see what the diagnostic analyzer does because we also want our behavior to be consistent with other attribute analyzers. So we look at the attribute analyzer here. What is this doing? Do you need to cache the source generator performance, or is it as a resolve each time the analyzer is invoked? Do you need to cache the source generator for performance, or is it fine to resolve it? So when we're resolving this, what's happening is this initialize gets called once, right? So this initialize gets called, we register for compilation start. Compilation starts, and the analyzer hook comes in. When that compilation is happening, we are going to look for the name type that we're searching for, and that's kind of where our caching has happened. So our caching happens at the beginning of the compilation, and then every time we encounter a symbol, we're going to go through, and we already have this cached name type. So it's kind of caching, but keep in mind that each time we do like a register, this callback happens. For compilation, this is every time like compilation happens. This is every time a symbol is encountered. So we are caching at the compilation level. Compilation does not get started on each keystroke. It's a little bit complicated. So there's some logic to determine how fast we do compilations and everything. That's really handled pretty well by the IDE, and specifically the workspace. So like every time you type a character, we're going to do like partial compilations and stuff. There's a lot of work going on, but this is not getting called on every keystroke. You can probably think of it closer to how if you see the like squiggles show up, it's probably more aligned with the cadence of the squiggles is the best way to put it. So that way you have a visible representation of what is going on with the compilation. When you see squiggles, we're going through and doing like as much of a compile as we can. And this might just be it, at least for the analyzer. Code fix is going to be a little different. Oh yeah, I got sidetracked. We were looking for where this diagnostic analyzer actually goes. So this one's a little bit more complicated because this one has language support, which we don't really care about. This one calls get applicable attributes. Let's do that. Let's call get applicable attributes then. We'll follow suit. And then we'll pass in this. And we just want to check to see if there's any attribute. And then where does this register? Blah, blah, blah. Symbol context. Report diagnostic, diagnostic. This doesn't actually include the location. Okay. Oh wait, no. Diagnostic location is on creation of the diagnostic. Where's create diagnostic? There's the rule. Oh, okay. So we don't actually have to include a location at all. So we're not going to. We do need to include a symbol.name here, and eventually we'll have to include that as well, because you can see that this takes a name type, so it's going to tell you what name, or I guess what symbol, is missing that. This is calling attribute syntax dot create diagnostic. Okay, so this is creating it directly on a syntax. So where does this syntax come from? Applicable syntax references. Oh, here we go. This is the missing diagnostic. So this creates it on the type itself. Okay, perfect. That's what we need. So we just need to do symbol.create diagnostic. That's the missing piece. So we use the symbol to do that. It's going to have the same behavior for location and everything. Perfect. And despite all of the squiggles, this is a fully functional analyzer. So this does not include the code fix, but this should report diagnostics saying if something is missing, then what is this error? And time called to be considered a diagnostic analyzer. Oh. Yeah, since we didn't use any language-specific stuff, we can go ahead and add VB support too. Because everything is based off of symbols. We should be okay on that front. And the last bit here is, should be one or multiple sentences. Yeah, I don't care. We'll figure that out in a second. I did not put very intelligible strings in there. Great. And this doesn't, oh yeah, let's make the code fix real quick. At the very least, we will create the code fix. So meta analyzers, fixers, new item. Oh, I already forgot what I called this. Oh yeah. So code fixers. These get a little bit more complicated, but they're not too bad. Let's go look at the other one real quick to just kind of show you. So this was apply diagnostic analyzer. So there's a few things about code fixers. You need to inherit from the code fix provider. You provide a list of diagnostic IDs that you can register to fix. When a diagnostic ID gets registered, you get this register code fixes async call, which has the context. So this will be whenever your diagnostic that you register in your IDs gets hit, you get called this. Because there are cases where that ID may be happening that you can't fix. So, we separate that logic out a little bit. It does provide the document and everything. And then you check to see if you can. And this kind of breaks this up a little bit, but if you can fix it, you have to add a code fix action or a code action. So you can see there's a few different things you can inherit from here. This is a document change action. Let's see, this one is C# diagnostic analyzer attribute VB diagnostic analyzer both. Okay. So yeah, all of these are going to be document change actions. And you can look at this issues if you want to, but basically for now, we always inherit from document change action with our own code action. So that way we have our own unique type for this code action. It has a title, has a registered fix, which gets a new document with all of the changes. That's kind of where the magic happens. And then an equivalence key. And then it registers the fix. So we kind of need to do the same thing. So we're going to start by inheriting from our code fix provider here. Where did our source generator? I'm already losing my spot. There we go. Every fixer in Roslyn having a code action called my code action was one of the most surprising things when I started looking at the code. It really is. I don't have a good explanation other than it's just surprising. I believe this is going to be public sealed as well. We're going to implement the abstract class here. We want to create an immutable array. We want our source generator analyzer. Diagnostic rule.id here. So it's the same ID that we're registering our analyzer for. Just stands out so much from the rest of the well-organized and neatly named bits. It really, it does. It's so surprising, and I hate it. But if we get good search tools, it's not too bad. Okay. So let's just assume for now all the cases we care about. We want to register a code fix for, because the analyzer won't provide things that we can't fix. I don't actually know why the other one doesn't have cases that it can't fix. Does it? Let's see, analyzer. Oh, this just does if it can't find the node and everything. Okay, that makes sense. So this is the original document that has the error or warning or whatever. we want to look at the diagnostics. I think we want to do a for each here for the diagnostics, but I'm a little just calls context.span. Oh yeah, because we'll only register anyways. So let's get the roots. We want to find this node. We want to get innermost for tie. And if we don't find anything, we can't fix this. So we'll just return earlier. Otherwise, we can register a code fix. We'll have a private class, my code fix. We'll inherit from a document code fix. Right? Document code fix. Document code fix. Where was this at? My code. Oh, code action. Maybe you should call it Andrew's code fix. Yeah, sure. Oh yeah, Sam will definitely. It is document code action, isn't it? Oh, document change. Document change action. Change action. There we go. Yeah, this will definitely not fly in code review, but it's not always important right now. We're here to learn stuff and have fun, and either remember to fix it before I put it up for review, or get feedback that I did it wrong. Okay, so we're going to register our code fix. Code fix takes the code action that we just made and the diagnostic that is being fixed. In this case, we did not base it off of a specific diagnostic. So I'm actually curious. If you use the span attribute, which diagnostic are you using? Oh. So we do find it based on the context span, but then we go through each diagnostic anyways. That's kind of funny. Cool. Because diagnostics also have a location. Diagnostic and context diagnostics. Yeah. We can just do it this way. Don't even need that. We'll move this up here. In this case, we want to continue. And register as code fix. So we're going to create a new action. Fix stuff is the title. We'll add that to the resx in a second. Does this have to be synchronous or asynchronous? It's a task. Okay. So this takes in cancellation token. The context document here, I assume, is always the same across this. This is an interesting separation where the diagnostics have a syntax tree and everything because they have a location. And how does that relate to the document from the context? Is it always the same? Who knows? Let's hope it is. Because it looks like in other places we assume it is. And then the equivalence key. We'll just pass in a string for now. We can generate our fixed document async method. And then this is going to be for this diagnostic. So the other bit we need here is the node we're actually going to be fixing. This still kind of makes me nervous that we do diagnostic location and document separately. Yeah, this is a weird, really weird interaction. If anybody's in the chat and knows why diagnostics have a location, but the code fixes also have a span, and are they guaranteed to be the same? I have no idea. That's kind of an important question. So let's go back to what we were doing before, because it does make me feel a little bit nervous that this is not actually correct. But we'll still go through each diagnostic and register a fix. Okay. So we want to make a few assumptions about this node. First is we need to be able to get the... We need to be able to modify this syntax, right? We want to add an attribute to our syntax here. So the first thing is this is syntax node is a type. Can we add, if we have a name type symbol, Can we add attributes to it? If not, then we want to do the other way around where we have a syntax generator. Oh, back button. Come on. There we go. Good. There we go. Want to get the generator for the document in here. And then we want with modifiers, accessibility with statements, type arguments. Add attributes. Here we go. So we want to add our attributes to this. We want to create our new attribute, which is generator attribute here. So we have to make this. So we're going to create a new attribute. Create an attribute matching the existing attribute data. No. Do we just create it by name? I guess we can just create it by name. Like if we just call this. Well, I have to worry about symbols and stuff too then. We can do the well-known type names that we used earlier. That's wild. Want to use the generator attribute name there. This is going to create a new node. So we want to do we'll use a document editor. They're a little bit easier to work with for generating things. So if we create this document editor, we'll move the cancellation token to the end soon, by the way, I promise. So we have our editor. We're going to use the editor's generator instead of creating a new one. Don't want to do extra work there. Created an attribute. So we want to do editor.replace node, and we're going to replace the original node with this new node. And this returns nothing, right? So this is all actions. And then we want to return editor get change document, not modified document. So let's move the cancellation token to the end. Cancellation tokens belong at the end. Rename it. And then we can make this static. Cool. So that's roughly all our code fix really needs to do, right? We're assuming that we need to always add this attribute, so we're going to go add this attribute. We don't have to worry about things like what language we're adding this attribute for, like the um, analyzer code fix does, because generator doesn't take a language. So this should just work. I mean, as much as code works on the first try anyways, right? So to go back to our tests, we can actually run it with fix code equals fix code. Cool. Is this namespace not correct? Oh, it doesn't override. Microsoft Code Analysis, Analyzers. Oh, it's not C# specific. There we go. We don't need half of this stuff. Let's get rid of that. Big money. Is this going to work on the first try? I think I'm really enjoying the fact that I can just play music on stream. I need some better music though. It's getting kind of repetitive. Like, it's not bad though. It's like, it is rocking for free music. Expected 1, actual 0. So we did not report a diagnostic here. So let's go debug why. So our analyzer is not working. So we're gonna check to see why this is not working. Okay. So do these types exist? Ooh. Okay, so those do exist. The symbol is generator initialization context. We don't care about that one. iSource generator, we don't care about that one. Custom generator, we care about that one. That's the one we're looking for. Okay. All interfaces is 0. Oh, that's not the correct one. We're looking at the wrong thing again. Custom generator. Let's put the breakpoint here. We're going through multi-threaded now. We enable concurrent execution. So we are all in Okay, here we go. Generator attribute does not apply. Wait, hang on. This is saying it already has the attribute? Or gets all attributes directly applied to the type or inherited from the base type. Okay. Get attributes. What is the point of this attribute usage attribute? If not, only include inherited. Gets. Oh. Okay. I misunderstood what this is doing. So, actually, I bet we find the references to this where we saw this in the diagnostic analyzer, attribute analyzer. You're going to see that it checks this, and then it goes through each attribute and still checks to see if it derives from the diagnostic analyzer attribute. So analyzer attribute usage. Attribute usage. Attribute. I don't even know what that means. But it still checks to see if that derives from the well-known type that we care about. So that's a fix we need to make. So if we go back to our analyzers, we want to pass in, I think, null here for now. And then we want to check to see if any of these attributes inherits from the source generator. Does inherits check to see if it's the same? So it derives from possible base types only. Where base types only will be true. Okay. So yeah, this does include the same type here, which is important because we want to make sure if it is the same type, derives from, still returned, or inherits returns true. Okay. And then we'll do this. We'll break on that. We don't need these breakpoints anymore. We've confirmed that those work fine. And we will just rerun our test. How is ignoring work going for y'all? Having a good time? All right, here we go. Moment of truth. Perfect. I mean, our test still failed, but at least it failed differently. You're perf tuning Orleans. All right, real question though. When it's by itself, is it Orleans or Orleans? Expected at the end of column 14. It was actually at column 29. What? So you're finally writing your test, David. Oh, neighboring state having a COVID outbreak. That is very unfortunate. So missing generator attribute, which is correct. It looks like we put this. So I expected at column 14, it was actually, so it looks like we're putting it at the end here. Which symbol did we put it on? It's on the name type symbol, right? Apparently that's where it goes. Okay. Sure. Well, that's good, Pedro. Glad you're enjoying the stream. This is lying to me. It says run test finished. But I know it's lying to me, right? It was actually column 14. Oh! I think I went I do think I went the other way. So column 14 is going to be, let's see here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14. What? What do we got? What do we got? Expected diagnostic, actual diagnostic. Oh, because the span goes across the whole type name. You know, that kind of makes sense if you think about it. If you think about things, you know, in an intelligible way, that actually makes sense. It also looks like the message is not expected by default. Here we go. Okay. Perfect. So this is fine because what we didn't do is include our references. So we need to make sure we're including our source generator references because this is going to be compiling it again. And once we get this kind of worked out and passing tests, I think we'll make this into a helper function. This is kind of annoying to write every time. But at least that's expected. So we're getting into the fixed state. It also means that the fixer technically is probably running. I'm not sure if it's running correctly, but it's running. Okay. Let's check to see if our fixer's running, because it looks like it's not actually fixing anything, you know? We still have the missing generator attribute on the fix code. Alright. Let's go ahead and return this. There is a fix-all provider that's common. That's what we need. Custom fix-all provider. Oh, whoops. I want to find all references on this. Well-known fix-all providers is what I'm looking for. Okay. And we want a batch fixer. Go ahead and provide the fix-all provider there. I'm not actually sure why this test isn't running. Let's look at this. So run async is what I would expect still, right? Because we have a fixed state, so it should know that we need to run the code fixer. So the code fixer is still not running. So why is that? We registered everything correctly, didn't we? Export code fix provider. Wow. Forgot to export it. Forgot to export it. Womp. Womp. That would explain why it's not running. All right, Fred. Thanks for stopping by. And thanks for the help earlier. Definitely appreciate it. It was good having you here. Have a good night, man. Okay. Export code fix provider. We did that. We exported the thing. Provided a list of things, like this should all be working now, right? This is what we should have. Let's get rid of the squiggle. It's annoying me. Why is the code fix provider not working? We register it with verify CS. Yeah. Alright. Alright. One thing we might be able to do is we put a breakpoint here and make sure it's at least registering, because it should call immutable array.create here. This code has to run. It at least verifies we're registering things. Okay. We're running. And the ID is RS1035. I mean, not crazy. I mean, it might be crazy, but at least not for this. Does this run the batch fixer? What are we doing here? Ooh, okay. This is stumping me. So we registered for RS1035. We know that we're getting called at least. We know the diagnostic rule here. Test.cs. And we know that is the context diagnostics of the fixed state. So, chat, what is going on? Our fixer's not running. Why is our fixer not running? Do we set up our fixer wrong? How did it? Code action index. Let's do it. Let's try it. Let's try setting the code action index. I don't understand. I'm not gonna lie, I don't really understand equivalence keys here. But let's try that. I'm feeling that's what it has to do with. Okay. Let's get our code action equivalency key, which, if you remember correctly, was fix stuff. Even though this isn't getting registered, because we would hit a breakpoint here, right? Like this is blowing my mind. Okay. So we are getting called. We're getting the fixable diagnostic IDs. Why are we not getting called back to register code fixes? These are just rule IDs, right? Diagnostic IDs. I don't even know why I used that. We can just do okay. I mean, it's the same string. Should be at least. Do I need to register the code fix elsewhere? That's a good question. That's what I'm trying to figure out. So, I thought export code fix provider with our fixable diagnostic IDs. This custom code fix provider I wrote, like I've done this before. The batch fixer. I mean, it's a good guess if we have to register somewhere else. The only change I made was changing this to be this diagnostic ID here instead of registering directly to the diagnostic from the other code. If that fixes it, I really don't think it will. Man, I was all prepared for this to just work. Okay. Verify CS has registered with this as a fix. And it's a fix verifier. What's the documentation on run async here? Verify fix async. Is that getting called by run async? It should. Code fix test behaviors. What is this? Let's try changing this, just in case this matters. Because I have had this matter before. Let's just fix one. That's all we care about. It's just one. We only want to fix one. Default is to fix all, I believe. Yeah. Then, I'm just guessing at things now. Fix state, sources, additional sources. We don't need to provide expected diagnostics. Just in case this is for some reason. So we're just going to concatenate this code together for now. It has to be test setup. It has to be, right? Oh, yeah. Our using clauses are going to be all messed up. What do we miss? Miss system. I'm like racking my brain on this right now. I don't know if it's because I've had a long day or what, but I cannot figure this out. Everything I know that registers code fixes means that this should work. Okay. So we're back to the same thing where we're fixed state and we're not running our code fixer. Okay, that at least is good that the test state setup wasn't different from verify code fix async. The usings in the namespace. So the usings aren't really the problem. When I was doing this to try to make sure that I'm doing this verify CS correctly, I wanted to make sure that it's basically the same thing as verify code fix async. The difference here is that I'm providing two different sources and I was just concatenating them together, so I needed to worry about my using statements. I didn't need to worry about them normally. I don't know why I'm blanking on like what this could be. We're registering the code fix. So this isn't getting called back. What else can we override in code fix provider? What is there? Register code fixes async and fixable diagnostics. So it's got to be that the fixable diagnostics are not correct. RS1035. Let's change how we report this diagnostic. Let's look at this for a second. Let's not add a description, first of all. Because I don't think that should be throwing it off, though. Oh, wait. Well-known type names. Here we go. Okay. This is where copy-paste got in my way. Resource manager, type of, code analysis, well-known type names. This is creating a resource string. But we don't need this. I don't know. I actually don't know if that should be it because I would think that the ID is the most important part. And this is the same ID. Like, this is the correct ID. Which is what it should be matching on. We're gonna run another test. We're gonna run a different test to see if our breakpoints are hitting. It's the only other thing I can think of off the top of my head. What? This breakpoint didn't get hit. But it definitely fixed it. Although honestly, that might have been just the wrong test to run. Does the test specify the expected diagnostic? So, from my understanding, oh man, the only difference between expected diagnostic and this is whether you have a custom message. So if you have a specific message, which we didn't do for this one, if you want your message to say custom generator does not have generator as an attribute, then we need to generate a specific thing. And we wouldn't use this annotation here. But with this annotation, this is saying there's the default diagnostic. We only provide one diagnostic. It's not customizable in message. So it's this diagnostic, which is correct. So we know our diagnostic is hitting. We just also know that our fixed state isn't correct. Square brackets usually is for selection. Curly braces are okay. Here's the thing. If I put this here, this test will pass. And it will say that these two differ. It will no longer say that. So this is just the testing infrastructure. So verify CS.test, like all of this testing infrastructure is around analyzers. So the C# code fix verifier and everything, all of that is around code fixes. And so they're really around diagnostics. At least I thought. This is blowing my mind because this is saying diagnostics of fixed state. And if I don't provide a fixed state at all, this test will pass. Which means that the analyzer is working at least, right? That's what, like, if I don't have a fixed state, then all it does is run the analyzer and verify that diagnostics are reported for the analyzer, and then the test passes. So we know that this diagnostic... Oh. Maybe you're right. Maybe that's the trick? So you're saying use curly braces like that. I thought if you did that, you had to do something like RS1035 : Yeah, I think that this is the same thing as what I had before, though. And this is still passing. So what's bugging me is the fixers are not getting called. Even when I was running under the debugger for another fixer, this register code fixes async wasn't getting called. Yeah, so we're back to this now. Okay. There's got to be... Final reference is this. Let's find test that uses this. Here we go. I was running the wrong test to get this. If this doesn't hit, there we go. Okay. This is at least a sanity check. Another code fix provider is getting hit. If we look at this call stack, we should see... Ooh. Let's look at this. I didn't realize all of this was, I thought all of this was in the testing library. Let's look at this. Oh, is this being brought in by source? This needs to be a diagnostic analyzer and a code fix provider. This is a code fix provider. I don't know what to do about this, people. I can't debug this, and it's not getting called, so this has an equivalency key. Is it because I'm not calling... Is there a constructor I need to call that I'm not calling? Like, what is happening? Let me be... Alright. Well, maybe Sam programmed it in so that way anything not named my code action doesn't run. It just quietly fails. Well, it still quietly fails, but that's not the reason. I don't know. This might honestly just be a... There's got to be something. It's going to be something really dumb, too. Where you have the same ID, right? Fixable diagnostic IDs. That's correct. Okay, here's an even easier one. We prefer is kind. Analyzer.rule.id. Okay, so they did the same thing I did before. Find who implements this. Do I need a name? Am I missing that? Is that provided elsewhere? Is that the problem? Shared here. We're using the right shared, all right? It's gonna be the name attribute, I swear. Alright, we're gonna run this. I'm gonna use bathroom whilst doing this. I don't know what protocol for using bathroom on stream is, but I know you don't do it on stream. So I'll be right back. Enjoy the test. Alright, chat. I'm officially out of ideas. This is like the most frustrating thing on stream too. Because it's gonna be something really dumb. Like really dumb. Like, this is gonna be so dumb when I figure this out. Okay. We're gonna start a new branch. We're gonna commit what we have. It's goodness. Like it's all good. You know, except for the not working part. Yeah. Now we're just gonna mess around and see if we can figure this out. Fix code. Like if we just use the same exact code. Like maybe there's a compilation error that I'm not getting. Okay, let's give it. Fix code should be the exact same. So code fix register is not exactly the same. Um, you're kidding me. Hang on. Hang on. Hang on. What did I just do? Wait a second. Wait a second. Generator attribute. It's an attribute. Okay. Okay. Don't understand this. What did I choose? What did I change? What did I change? Yeah, generator attributes right here. So here's the interesting thing. This is confusing. Yeah, I created a new branch. I removed the generator attribute. So this is giving a warning with missing generator attribute. And our code fix is not being applied. It's also saying expected 0 when I clearly have it right here. That should be expecting 1. So, hang on. Okay. What if the problem is this is some because what if our code for determining diagnostics is wrong? Because remember, if I remove this, which looks a lot like how we have diagnostics to begin with, and run this, it runs the code fix and it fixes it. So the code fix is working. It's literally just test code. I'm gonna kick something in a second. Hang on. Hang on. Let's go back to our analyzer. Because that's the only thing that's reporting. Right? So when we're reporting a diagnostic rule, we just see this report once for the initial correct diagnostic, or we fix it. Okay. And we want get attributes here. So let's look at this list of attributes real quick. So we're going to see 0 attributes. Okay. Still 0 attributes. 1 attribute. Microsoft Code Analysis generator attribute. So it has the attribute and it's still incorrectly reporting it. That's what it is. Our analyzer is broken, but it's showing up in the fixed code because the fixed code is still reporting a diagnostic. What I don't get is even putting the diagnostic thing in the fixed code didn't work. But I bet if we don't report that diagnostic at all, we just keep ignoring it. This test passes. If it passes. Ooh, it passes. It had added it twice. Because it thinks it doesn't have... Okay. The analyzer's broken. How do we generate the correct... Well, let's make sure we're generating the correct... Oops, that's not what I meant to go. Yeah. Okay, let's go to definition here. New literal. Try to get fix info. What is this doing? So we're creating an attribute, but we're creating the wrong attribute. That's really it. The symbols are just not comparing correctly. Which is crazy. Okay. What is attribute data? But it's adding the attribute. It's literally the same type. Okay, okay. Let's change this up. So let's do when symbol attributes dot any. And let's go back to our test. So we want to see what's failing here. This check. This check, like this line 55 right here is the failing case. That's the problem. So our symbol has attributes. These attributes are generator attributes. Type, name type, generator attribute, possible base. I sourced generator. I sourced generator. Naming is hard. Found it. That's the bug. Test is gonna work now. I can't believe I just passed in the wrong type to inherits. That's all I did. Literally just the wrong name type symbol. And it showed up in the oddest way. Yeah. I should... whatever. Whatever, it works. You wanted your analyzer? You wanted your code fix? Here it is. Here it is, people. This is what you get. Oh. No, that's good. I'm glad I figured it out. I'm gonna go ahead and commit this. I type attribute. Okay. Well, I need to write more tests for this, but that's enough time for the stream today. Thanks for joining in and watching me struggle us through figuring out how to type attribute. Hopefully you learned a thing or two about analyzers. And you got to kind of see if something is not working, how I would diagnose it, which is really just to scream at the screen a lot, but there are a few steps you can take. This code needs to be cleaned up a little bit. I'm going to write some more test cases. I might wait till next week on the stream to do that, or do it before. We'll see. But I won't be putting out pull requests right after this, which is usually the goal from this stream. Yeah, this is the realest of reels that you get. It has been a lot of fun, though. Thanks, everybody, for joining. I'm going to go eat some dinner and celebrate that I wrote a functional analyzer that passed a single test, and potentially more. I'm going to write some more tests, and we'll see. I will try to catch y'all hopefully next week. I think weekly is starting to be a good cadence for me. I definitely seem to have at least gotten a lot of the initial problems with streaming worked out, so I think getting used to it, getting used to talking to myself for a while, got technical difficulties worked out, and I'm really enjoying it. So if you have suggestions on what you want to see in the stream, we'll either go back into analyzer stuff next week, or since it's going to be writing tests, maybe not. Maybe we'll just go back to simple code fixes or bug fixes for Roslyn again. I know there were some requests to go over more of those. Or if we're feeling really spicy, maybe we'll go look at some inherit doc stuff. It's an area I need to learn more about. So, but it was a lot of fun. Thanks for hanging out with me, and I will catch y'all next time.